Okay, welcome back, guys. This video we're looking at cubic functions now, and so polynomials that have a degree of polynomial degree 3 or highest power, or has a term that has the highest power of 3. So you could have something like y equals x cubed, or you could have something like y is equal to x plus 1, x minus 2, and x plus 3. When you expand those brackets, you'll end up getting a polynomial or cubic function. The interesting and I guess cutting to the chase, when we're graphing cubic functions, that is your factorized form. And if you were to apply the null factor law, okay, so null, not at all, NFL for null factor law, you'll end up having solutions for x being -1, +2, and -3. And they're going to be your x-intercepts for this cubic function. Obviously, different cubic functions will not always have 3 x-intercepts. Could have 2, could have 1. So we're just going to go through this. I'm going to revert to another program to highlight what cubic functions can look like, but I just want to go straight into a table and to sketch some points and see where it goes from there. All right, so let's draw up a table for the graph of y is equal to x cubed minus 1. Okay, and so our input and output we'll get -3, -2, -1, 0. And we're going to substitute each of these values into for x to work out what our output values are. So when we have -3 all cubed minus 1, we get -27 minus 1, which is -28. If we end up having -2 all cubed minus 1, then we'll have -8 minus 1, which is -9. And then if we do -1 all cubed minus 1, we'll get -1 minus 1, -2. And we continue that process, we'll have -1, 0, 7, and 26. Then what we can do, now that we've got our coordinates, we can plot this on the graph. So 1, 2, 3. Obviously my graph is not the best and not to scale. 5, 10, 15, 20, 25. And so when x is -3, we have -28. So I'm just going to put it there. -2, it's -9. So it's about there. -1 is at -2. So it's about here. 0, it's at -1. And at 1, it is at 0. And then 2, it's at 7. And 3, it's at 26. So what we'll end up having is our cubic function looking like that. Okay, simple as that. If we were to substitute into another, I guess, equation, which, for example, y is equal to x, x minus 2, x plus 2, you could have your table of values again and just jot them down. Okay, or what we could see is, as I just pointed out before, we've got our x-intercepts here. So null factor law, x equals 0, +2, and -2. So what will happen here is that our x-intercepts are at -2, at 0, and +2. Okay, now the situation here is, well, we want to know where it's going to start, where it's going to finish, and how it's going to go through those 3 points. So let's substitute f of minus 3, and f of minus 3 is going to be equal to minus 15. If we have f of 0, substitute 0, it's all going to be 0. And then if we say f of positive 3 and substitute a 3 into f of x, then you'll end up getting positive 15. Okay, so what we'll end up having is f of minus 3 is at minus 15. So we're looking here, it's going to also be at f of 3 at positive 15. It's going to be here. So cubic functions are going to look like that. Okay, and so we need to work out that kind of shape within this. Now, the one thing that we can see, it's going to cut through the y-axis. So let's work out what the y-intercept is. Our y-intercept is when x equals 0. Okay, so when x equals 0, 0, and 0, it's going to be at 0. So here we've established that already. So what I can suggest is going up, certain point is going to go down through there, and then it's going to go back up. And remember, we're not worrying about turning points at this stage. If you want a little bit more accuracy, what we can do is we can substitute f of minus 1 and f of 1. And so f of minus 1, if we substitute minus 1 into that function, we'll end up getting 3. And if we substitute 1, we'll end up getting minus 3. So we can see that my turning points are not quite right. Minus positive 3 and minus 3 is about there. So the curve is just a little bit less. Okay, but at this stage, it's not going to be too much of a bother. I want to just focus on getting the X-intercepts here and just getting just a basic introduction into cubic functions and what they look like. So we're just going to do a few more examples just to get this into practice. Y equals x minus 2, x minus 3, x plus 5 is a cubic function. Y is equal to x minus 6 all squared. 4 minus x is another cubic function. And then y is equal to x minus 2 all cubed as a cubic function. Now, x-intercepts here, we can see that it is positive 2, positive 3, and minus 5. We can see that the x-intercepts here, there are only 2 x-intercepts. It's positive 6 and 4. And then in this case here, we only have one x-intercept, which is at positive 2. All right, so let's have a look at this at the graph. But before we get to that, we want to work out what the y-intercept is for each of these functions, okay? And in order to do that, you make x equals 0. So when x equals 0, we've got minus 2 times minus 3 times 5. So what we'll have is positive 6. So the y-intercept is at 30 for this particular question. In this case here, we'll have minus 6 all squared times 4. So 36 times 4 is going to be 144. And then when we have minus 2 times minus 2 times minus 2, our y-intercept is going to be minus 8. All right, so for the first graph, what we'll do, and these are just sketches, okay? So positive 2, 3, so let's go 1, 2, 3, 4, 4, 5, minus 1 is 2, minus 3, minus 4, minus 5, okay? So we know that it's going to cut through this point, it's going to cut through this point, and it's going to cut through this point. We also know that it has a y-intercept of 30, and obviously this is not to scale, but that will do for this point in time. And if it's going to go up through here and down through here, we can say that it's going to look like that at this point. Probably not the best of sketches, and then it's going to go down here. Okay, now the turning points do not need to be symmetrical, so just keep that in mind. So that's going to be the first sketch. All we're focusing on are our X and Y intercepts. Let's move on to the next graph, where we only have two X-intercepts. The two X-intercepts are 6 and 4. So what we'll do is just go 2, 4, 6. And then we know that our y-intercept is at 144. So it's a lot higher. So when we think about what this graph looks like, it's going to start up high, it's going to go low, and it needs to go back around and then down again. So going through here, and it will look like that. Okay. The last one, which is a little bit different to the other two, is that there's only one X-intercept. And so what we have is, I guess, the origin. We've got our X-intercept being 2. We know the y-intercept is -8 in this case. Sorry, not 8. Because -2 times -2 minus 2 is -8. And therefore, we're going to have this kind of graph, but within the context of just these 2 points. So what will happen is something like that, okay, where you still have this kind of curve, but it's only going to meet the x-axis at one point. All right. If you're ever unsure of the direction, please just maybe utilize a table, use your graphics calculator to get some confirmation. I'm just going to divert to Desmos just to show you what they look like. So again, it's just the sketches that we've already done before. So here we have our cubic function of x to the power of 3. And what we did was x to the power 3 minus 1. So when we think about this constant of -1, it's going to do a vertical translation and shifting the graph down 1 unit. We did then x times x minus 2, x plus 2, and we could see that they are the 3 points of intersection, -2, 0, and 2. And by substituting, say, value of 1 and -1, we're able to just indicate a little bit more where the turning points are, or just approximately. Then we have this next one that we did. And if I just zoom this out a little bit, because we had, I guess, we didn't really know what our turning points were. But again, this is something that I don't want to really stress at this point in time, but you can easily substitute your values if you need be. So we found out that the y-intercept was at 30. Obviously, it was going to go a little bit further up, which it did, before coming back down and cutting through the x-intercept at -5. Okay, and then we moved on to a cubic function which has 2 x-intercepts, and here we have 4 and 6, and obviously 144, it went all the way up to the top, and then our last one was the cubic function which had 1 X-intercept, and we could see that it went up through -8, touched the x-axis at +2, and went back up. So hopefully that helps you guys for today. If you have any questions, let me know. We're going to move on to quartic functions, which are polynomials of degree 4. So see you then.